Our objectives in this lesson are the following. Illustrate a scatter plot, construct a scatter plot based on the given data, and describe the relationships of variables in terms of form, trend, and variation. Let's have a quick activity. Plotting sales. Sydney decided to sell noodle soup in cups because of the cold weather. He started selling last February 1. On the right are his daily sales for the past week. What we are going to do is to plot this data in a Cartesian plane. Let me have my x-axis first, then my y-axis. I will label my x-axis as date and my y-axis as number of cups sold. The smallest number in the number of cups sold is 12, so let me create a gap here and let us put some grid lines to help us in graphing. The intersection of the y and the x-axis is 0. Smallest number again is 12, so this will be 12. And then I choose an increment of 2 for the numbers of cups sold. So 12 plus 2 is 14. This will be 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, and 36. For the date, I'll start with Feb 1. That would be 2-1. Then 2-2, 2-3, 2-4, 2-5, 2-6, and 2-7. Let us start for February 1. He sold 21 cups. February 1, 21 cups, so that would be here. February 2, 23 cups, so that would be here. February 3, 35 cups, so that would be here. February 4, only 13 cups, so that would be here. February 5, 35 cups again here. February 6, 12, that would be here. And last one, February 7 is 14, and that is here. And we're done. What we created here is somewhat what we call a scatter plot. A scatter plot, also known as a scatter graph, a scatter chart, or a scatter diagram, is a plot of ordered pairs x, y of bivariate data on a coordinate axis system. It is a visual or pictorial way to describe the nature of the relationship between two quantitative variables. A scatter plot describes the overall pattern and deviations from the pattern. For the overall pattern, we have the form, trend, and variation. And for deviations from the pattern, we have what we call outliers. Let us start with the overall pattern, the form. The form determines the shape of the correlation of the variables. Take a look at these pictures. From here, you can resemble a line in here. So this is called linear. While in here, as if you can form a curve, so this is what we call nonlinear or curvilinear. Sometimes we also have these two. In here, you can see that the points are very close to each other. This is what we call clustered or concentrated. And in here, the points are far away from each other. We call this scattered or spread out. Let's have an activity. Determine the form of the scatter plots. This one is very easy. From here, we can form a curve. So this is nonlinear or curvilinear. This one, the points are closer to one another. We call this clustered or concentrated. While in here, you can see that there is a trend of a line. So this is linear. And here, very obvious, the points are far from each other. We call this scattered or spread out. The next one in overall pattern is the trend. The trend determines the direction of the points. We have here three pictures. This picture number 1, you can see a rising trend of line from the left going to the right. This means that as your x increases, your y also increases. So both variables move in the same direction. So if your x is decreasing, your y is also decreasing. You can still form a trend of line rising from left going to the right. If this is the pattern, we call this positive correlation. Picture number 2, there is a rising trend of line, but this time from the right going to the left. In this case, if your x is increasing, your y is decreasing. So one variable increases, the other one decreases. If this is the trend, we call this negative correlation. While in here, it is neither positive or negative. There is no relationship between two variables. We call this no correlation. This is somewhat similar to your lesson in slope of a line. If the line leans to the right, the slope is positive. If the line is leaning to the left, the slope is negative. And if you create a horizontal line, then the slope is 0. Let's have an activity. Trending now. Determine the trend of the scatter plots. Quite easy. From here, you can see a pattern. It is a rising trend of a line from the right going to the left. So this is a negative correlation. While in here, it is a rising trend of a line from the left going to the right. This is a positive correlation. And since the points are scattered or spread out, then we have no correlation here. Another activity, what's trending? Determine the trend of the following. Column 1 is for variable 1, column 2 is for variable 2. Now, is there a correlation between height and time spent watching TV? I don't think so. So we have here no correlation. How about the age and fear of monsters? When you were young, you were easily threatened or you have fear of monsters. But as you grow older, your fear of monsters goes down. So here, one goes up, the other one goes down. This is a negative correlation. Number 3, number of workers and time to finish the job. The idea is the more workers you have, the lesser the time you need to complete a job. So as your number of workers increases, the time to finish a job decreases. Also, negative correlation. How about this one? Hours of overtime and the salary. In general, working beyond the working hours, what we call overtime, has a corresponding additional pay on your salary. So the more time you render for overtime, your salary gets higher too. So this is an example of positive correlation. Next one, number of absences and effect on grades. The more absences you have in school, the more lessons that you have missed. So the effect on your grades will be detrimental. It will go lower. So number of absences increases, effect on grades decreases. Another example of negative correlation. Next one, weight and income. Do you think there is a correlation between the weight of a person and his or her income? There is none. So no correlation. Last one, length of hair and amount of shampoo. The longer your hair, the more shampoo you are going to need. So length of hair increases, amount of shampoo also increases. This is a positive correlation. Next one in overall pattern is the variation. The variation determines the strength of correlation of the variables. So here I have created a table. The variation may be perfect, strong, or weak, both for negative and positive correlation. And if there is none, then we have no correlation. Let me start with this one. For no correlation, the value of R is equal to 0. R, by the way, is what we call correlation coefficient. We are going to compute for its value in our next lesson. Here is an example graph of R is equal to 0. So you can see the points R is scattered and no pattern can be seen. I'll discuss this one first. The next one is weak positive correlation. The range of R for weak positive is from 0 to 0.5, exclusive, meaning 0 and 0.5 are not included. Here is a sample graph. And from here, you can see that the points now are a bit far from the trend of a line rising from left going to right. So there is a trend of line, but the points are a bit far from the trend of line. The next one, we have the strong positive. The range is from 0.5 to 1. 0.5 inclusive, meaning 0.5 is included, while 1 is exclusive, not included. Here is a sample graph. Comparing these two graphs in here, points are close enough to see a trend of line rising from left to right. And if our R is exactly equal to 1, we call it perfect positive correlation. Here's an example of a graph. Here, there is a perfect trend of line leaning to the right, rising from left, going to right. Let me continue here. For weak negative, this would be from negative 0.5 to 0. Exclusive, meaning on the number line from 0 to negative 0.5, but 0.5 and 0 are not included, that is weak negative correlation. Here is an example graph. So just like in here, points are a bit far from the trend of line, this time rising from the right, going to the left. You can see these points, they are quite far from the trend of line. Next one is the strong negative. This time is from negative 1 to negative 0.5. Negative 1 exclusive, not included, to negative 0.5 inclusive, included. Here is a sample of the graph. So here you can better see that the points are close enough to see a trend of line. And the trend of line is from the right going to the left. And if our R is equal to negative 1, that is perfect negative correlation. Here is a sample graph. So this, we have a perfect trend of line leaning to the left and rising from right going to left. Actually, this range here is not definite. There are other books that uses other range, just like this one. So if your teacher give a different range for this particular lesson, use the one given by your teacher. But in this video, I'm going to use this range here. Now let's have an activity. In plots, there is strength. What we are going to do is to determine the variation here as well as the trend. So here you can see that there is a trend of line and our R is equal to 0.63. 0.63, this is in between 0.5 and 1, so we have a strong. And since this is positive, so we have a strong positive correlation. Here you can see that there is somewhat a trend of line here and R is equal to negative 0.39. This value is in between 0 to negative 0.5 on the number line going to the left. So this is weak negative correlation. This one, R is equal to negative 1, a perfect negative correlation. And R is equal to positive 1, perfect positive correlation. Here, our R is equal to 0.94, but very obvious that this is not a line. It is actually a curve. So this is a strong positive curvilinear. For the last one, our R is equal to 0, but you can see that there is a strong curvilinear relationship. Let me discuss this further. If I'm going to ask you to estimate what is the value of R in this picture, and if your answer is 0, then you are correct. Here is another picture. You see earlier that the value of R here is also 0. Let us analyze. A correlation of 0 does not mean zero relationship at all. Rather, it means zero linear relationship. As you can see here, R equals 0 could be zero linear relationship or a strong curvilinear relationship. So this means correlation coefficient R only measures linear relationships. If that is the case, if you are given two quantitative variables, you have to look at the data first and use the correlation coefficient if there is a linear relationship, meaning you are not going to use R if the relationship is curvilinear. Next thing that we are going to talk about is the outlier. Outlier is a point that does not fit the rest of the data and does not follow the pattern. To explain better, let me show you this simulation. I found this simulation in the internet from this website. I want you to focus your eyes on the value of R here. Now I am going to create a scatter plot. I have created a perfect negative correlation. The value of R here is -1. But look what will happen if I'm going to move this point away from the trend. This time, the value of R is -0.56. So this means the outlier has an effect on the value of R. Let us try another one. This time, I have created a scatter plot with R equals 0.95. But if I am going to add an outlier point like this one, the correlation now becomes 0.57. Another one here, it becomes 0.33. So this means the outliers have an effect on the value of R. From the simulation that you have seen, we can say that the correlation coefficient is sensitive to the outlier. When you are plotting the points on the Cartesian plane, it is important that you know which is the independent and dependent variable. So here is a Cartesian plane. We know that this is the x-axis, while this one is the y-axis. The independent variable is always plotted to the x-axis, while the dependent variable is plotted along the y-axis. To help you remember this, let us have an example. Let us say you have a point M with coordinates 3, 2. What are you going to do to plot this point? Isn't it from the origin, since 3 here is positive, you are going to move 3 units going to the right. And then since 2 here is positive, you are going to move 2 units going up. And there you are. There is your point M with coordinates 3, 2. So what did you do? From the origin, you move first on the x-axis. And since the x-axis is where the independent variable is plotted, then the independent variable always happens first. So to help you remember which one is the independent variable, take a look at the situation. Ask yourself, which one happens first? The answer to that question is the independent variable. The independent variable causes or determines the dependent variable, while the dependent variable depends or relies on the independent variable. Let's do extra challenge. So in here, we are going to create the scatter plot, and then I am going to give the value of R. Then we are going to determine the form, the trend, and variation. By merely looking at this table, we can see that as the number of minutes is spent in studying increases, the scores generally increases too. So I would say that this will create a positive trend. Let us prove that by plotting. Let's have the Cartesian plane. Ask yourself, which one is dependent to another? I believe the scores are dependent on the number of minutes is spent on studying. So this will be our independent variable. We are going to plot this in our x-axis. The smallest number is 10, the highest number is 90. I'll choose an increment of 10. So this is 0, this will be 10, 20, 30, up to 90. Now, for the scores in the exam, the smallest number is 5 and the highest is 30. I'm going to plot this in the y-axis. I'll choose an increment of 5 this time. So the first one is 5, then I have 10 going to 30. Now let us plot. For 10 minutes, the score is 5. 10, the score is 5. 20 minutes, the score is 8. So we have here 8. For 30 minutes, the score is 12. 12, there you are. Next, we have 45 minutes. That is in between 40 and 50. And the score is 15. So here. Next, we have 60. The score is 22. So somewhere here. Next, we have 75. That is in between 70 and 80. And the score is 34, somewhere here. And last one, 90. And the score is 30. Here you go. So I could say that indeed there is a trend of line rising from the left going to the right. Now let us say we already know how to compute for the value of r, and the value of r of this scatter plot is 0.96. Now let us determine the form, the trend, and variation. The form, as you can see, a trend of line, therefore this is linear. For the trend, since this is positive and the line rises from left going to the right, so this is positive. And for the variation, 0.96 is in between 0.5 and 1, so we have a strong positive correlation. Let us have another one. This time we have age and hours is spent on new app. By merely looking at this table, as you grow older, the hours is spent in exploring new apps generally decreases. So I would say that this will create a negative trend. Let us prove that by plotting which one is independent and dependent variable. So the age is the independent variable. Whatever happened, you will grow older each year. So I'll put it here on the x-axis from 12 to 20. And then for the hours spent on the new app, that would be on the y-axis. The smallest number is 1. The highest number is 6.3. I'll just use an increment of 1. So 1, 2, 3, up to 6. Now let us plot. For 12 years old, numbers of hours spent on new app is 2 hours. 13 years old, 6.3. So that would be somewhere here. 14 years old is 4.5, in between 4 and 5. 15 years old is 6.2 here. 16, 5 hours. 17, 3 hours. 18, 4.5 hours. 19, 3 hours. And 20, 1 hour. So obviously, there is a trend of line here rising from the right going to the left. Let us say the value of r of this scatter plot is negative 0.43. Now let us determine the form, the trend, and variation. So the form, you can resemble a line here. So this is linear. The trend, since we have negative 0.43, so it is negative. For the variation, negative 0.43 is in between 0 and negative 0.5 on the number line going to the left. And that belongs to weak negative correlation. And this one here is what we call an outlier. For the summary, here are the things that we discussed in this lesson. Take time to understand this. Now, it is time to check your understanding. Pause this video for more time. Let us answer. What we have here is grade level and the average grade. Well, as I look on this table, I cannot see a pattern. There is no particular trend. Let us prove that by plotting. Here is the Cartesian plane. So you won't have an average grade if you do not enroll in a particular grade level. So the grade level will go to the x-axis. So from 1 to grade 10. Now for the average grade, the lowest value here is 84. Let me just start with 80 and then an increment of 2 going up. So 80, 82 up to 100. Let us plot for grade 1, 88, 188 here. Grade 2, 94 here. Grade 3, 86 here. Grade 4, 84. Here you go. Grade 5, 92, there you are. Grade 6, 86, there you are. Grade 7, 94, there. Grade 8, 84, here it is. Grade 9 is 92, there you are. And grade 10 is 88, Here it is. So really, there is no pattern. This is neither positive nor negative. And upon computing, we found out that our R is indeed equal to 0. Now let us determine the form, the trend, and variation. Since the points are far away from each other, they are scattered. Since they are scattered or spread out, then there is no trend, none. For the variation, we have no trend, so therefore we have no correlation. Gets? I hope you understand our lesson for today. Feel free to write your comment below. For our next lesson, we are going to discuss calculating person sample correlation coefficient.